Now we will work on Fall 2011 Math 115 Test 3, number 25. It's a word problem. A boat traveled 30 miles downstream in 3 hours and made a return trip in 5 hours. Notice that when it says return trip, we know that it traveled the same distance. Well, you go downstream 30 miles means you go upstream, return trip 30 miles as well. Now, when it goes the return trip, it's 5 hours. Okay. Now the question is, we need to find the rate of the boat in still water. Let's see step one. Step one, let B be the rate of the boat in still water. And of course we can see that because it goes downstream, then we can assign a variable, let's say a variable C be the rate of the current. Right? Now let's see. The second step, we will set up the equation, the system of equation that we need to solve. 30 miles downstream, 3 hours. The time is 3 hours. The rate will be, because it goes downstream, then it will be the rate of the boat in still water increased by the rate of the current. Right? Think about it. You go downstream means if your boat goes to that direction and the current push the boat, then it gets faster, right? And the rate times the time times the rate is the distance. In this case is 30 miles, and that gives us the first equation. The second equation, the return trip is 5 hours. Notice that because it goes return, then the distance will be the same, 30 miles. The time is now, instead of 3 hours, is 5 hours. So in 5 hours it traveled the same distance, but the rate of course will be different, because when you go opposite way, when you go return, then you will be upstream. Therefore your rate will be slower. The rate of your boat will be slowed down by the rate of the current. Right? Now that's the setup of the equations. Now step 3, we will solve that system of equations. Now instead of doing distribution, let's do this. We see that 3 times something equals to 30 means that thing, this group B plus C, is equals to, as you can guess, that's equals to 10, right? You divide by 3 both sides. Likewise, the second equation, 5 times something equals to 30 means that thing, B minus C, is 6. Okay? Now, so what happened is this. Instead of doing distribution and later on we need to eliminate B or C, we divide the first equation by 3 both sides and the second equation by 5 both sides. It gives us a lot nicer structure in which it's easier for us to solve from here actually. Now the question is to find the rate of the boat in still water. According to our definition, we basically need to solve for B. Now here the system has opposite coefficients for the C, which means if I add these 2 equations, I have B. The C will get eliminated, right? Now if I go on, then B equals to 8. In regular system of equations, once we get a variable the value of one variable, we need to plug this into either this one or that one to find the other variable. In this case is c. But in this question, they don't really ask, the question does not ask you the rate of the current, even though you can find it out. But that's not the one in question. You can tell if b equals to 8, if I plug it in here, then the c equals to 2, right? But that's not in question. The question only asks us to find the rate of the boat in still water. Now, the last step, of course, we need to summarize. So, the rate of the boat in still water is 8 miles per hour. Okay.